In this video, I want to provide you with some information about commercial structural framing systems. This presentation will cover the purpose of structural framing, low-rise framing systems, cast-in-place concrete, structural steel, load-bearing walls, hybrid systems, cost, and structural efficiency. The purpose of structural framing is to provide strength and stability. Strength holds the structure up and holds it down despite gravity or vertical loads and lateral or sideways loads. Stability maintains the shape and minimizes movement. Low-rise commercial framing systems may be similar to residential construction. It could include wood framing or light gauge steel framing. However, usage of commercial buildings often differs from residential usage. Because commercial buildings are subjected to heavier loads and more wear and tear, commercial buildings must be stronger and more durable than typical residential construction. They often provide larger open spaces. In addition, the owners of commercial buildings desire easy, low-cost maintenance. Common commercial framing systems could include cast-in-place concrete framing, structural steel framing, load-bearing walls, or hybrid systems. With cast-in-place concrete framing, forms are built, reinforcing is placed, and concrete is poured and finished in place. The left picture is an example of wooden forms that were used to cast the concrete slabs. The center picture is an example of cast-in-place concrete that can be formed to almost any shape. The right picture is an example of concrete that is poured to higher floors. Here you see examples of concrete columns and structural concrete slabs in cast-in-place concrete framing. With structural steel framing, structural members are fabricated off-site, members are delivered to the site, and members are erected per the design. Here you see examples of structural steel columns, open web steel roof joist, steel decking, structural steel floor beams, and lateral braces in structural steel framing. Load-bearing walls can be made of masonry, precast concrete, or tilt-up concrete. The floor and roof can be made of wood framing, light gauge steel framing, or structural steel. The example on the top left is an example of masonry load-bearing walls with light gauge steel trusses. The image on the bottom left is an example of tilt-up load-bearing walls with structural steel and open web steel joist floor and roof framing. Here is an example of open web wood floor joist on a load-bearing CMU wall. Hybrid framing systems combine two or more different framing systems. Here you see examples of structural steel framing and cast-in-place concrete load-bearing walls. The cost of construction is an important consideration when choosing a structural framing system. The cost of a structure is directly related to the weight of materials used to build the structure. Lower material weight equals lower cost. Higher material weight equals higher cost. Structural efficiency is the ratio of the maximum design load that a structure will carry to the weight of the structure itself. Higher structural efficiency means less material weight, which equals lower cost. Lower structural efficiency means more material weight, which equals higher cost. Here you see the formula for structural efficiency. The maximum design load is divided by the weight of the structure. The design load is the load a structure is designed to carry.